Okay, so geometric series now, section 1.4. So you can assume, or you probably have looked ahead, that we're going to talk about summing a geometric sequence basically. So we're interested in, as you can expect, the sum of n terms of a geometric series. Now, I'm not going to get into this, but it is fascinating. I've spent quite a great deal of time talking about or studying fractal geometry. Here is just a very, very brief outline to how geometric series is involved in fractals and fractal animations and so forth. So take a look at that. It's very cool, and watch this little documentary at the bottom here, which is really cool. So I'm going to get into the practice problems. First of all, there are going to be two formulas. Here's the first one we're going to be using. It's a bit long, but all the terms are the same. And this proof, and I apologize for how ugly it looks, but this is how you go and derive that formula, which I think is important to understand. So, moving along into the first practice problem. I'll do part A and I'll give you the solution to part B. So it says determine the sum of the first 8 terms of the following geometric series. You of course could do this manually, but that would be monotonous. And of course you wouldn't be able to do that with a lot of terms. So here we go. So first of all, here's the formula. Okay, I'm going to try to write neatly. Very difficult in this little writing pad in this program, but I'll do my best. Okay, that is the formula. R cannot equal 1. If it equaled 1, then you'd have a 0 on the bottom here. Okay, and so this would be undefined. So it can't have that. So T1 is 5 in this series. Okay, R is pretty easy to find. 15 divided by 5, or 45 divided by 15 will be 3. And there you have it, right? We're looking for the sum for the first 8 terms. So n in both of these questions will be 8. So S8, we're just going to plug and solve. Okay, and I'll pretty much leave I'm going to leave the solving to you here, but and I'm assuming we can all solve this question, right? 3 to the power of 8. You're going to have to compute that, and then minus by 1 times by 5 divided by 2, right? So this is going to come out to be 16,400. Okay, that's the sum. It can grow quite quickly, as you can see, just in 8 terms. The solution to the next problem is 85.3. You're going to get a decimal. Okay, so that's the solution. Same idea. Okay, same idea. 1/4. You can also treat this, by the way, as 0.25 if that makes it easier for you to compute. Okay, so that's practice problem 1. Now here's the second formula. We're going to use this formula in the next question. The second formula uses Tn. Okay, that's the only difference. Whereas the first formula back here doesn't have Tn included. So you're going to use this one, which is a variation of the first one, when you're given the final term. So here you're given Tn, and it's asking you to sum this. So this time you're not given, guess what? You're not given n. Right? You don't know what n is. But that's okay, because this formula does not depend on n. You don't need to know it. All you need to know is the final term. So we're not going to even look for n. We know what T1 is. It's 1/64. R is going to be 1/16 divided by 1/64, which will come out to be 4. I believe that is. Yeah. 64 divided by 16 at the end of the day. The computation is as such, though. That's what you have to do. Okay. Which will come out to be 4. Okay, so once you're given that, this question is a plug in and compute question. So I'm using the formula in the previous slide, or 2 slides ago, this formula right here. So we have r times Tn, which is 1024. We then are going to subtract that by 1 over 64, which is T1. And you're going to divide that all by r minus 1. When you compute this, you're going to be left with 1,365.33. So as long as you decide on the right formula, this is a very easy section. For this next one, I'll give you the solution. And the solution is Sn is equal to negative 5,462. Okay, that's the solution to the next one. Please try it and compute and ask me if you have any questions. And I'll see you on section 1.5.